Hi, good evening, everybody. This is Kevin with Map Practical. So tonight we're going to be going over a demonstration tutorial on how to make dot density maps, specifically of the current COVID-19 cases and deaths in the United States. So the instructions for this dot density map, it's for my GIS applications class. It's our lab 4, but that doesn't matter. I give you guys a little bit of background about coronavirus and where it came from with all the citations of where I'm getting my information from. And so we're going to map the current cases as they were on March 28th, and then also create maps of a best case scenario and a worst case scenario. So I cite some Washington Post articles and New York Times that talks about the range of infection rates for the whole world, which is going from about 1% to 50%, and that's from the CDC. And then the rate of mortality, which is about 0.25% to 3%. Now the WHO and the European CDC have some higher rates, including a 70% infection rate and a 3.4% mortality rate. But I'm just going to stick with the USCS, or Centers for Disease Control data. That's what I'm trying to say. All right, so let's move this on over here. Many of you have probably seen this map. Johns Hopkins University put out this dashboard way back in the beginning of the year, and I first showed this to my GIS class maybe in January, first or second week, and there was only about 3,000 cases in China, and this thing has just grown exponentially and now has infected people in almost every country in the entire world. So the data for this comes from the CDC, excuse me, and the GIS data is hosted by Esri, Environmental Systems Research Incorporated, the main producer of GIS software. So this hub has a ton of great data for your mapping projects, including some change over time data that would be really interesting in an animation. So I send you the instructions over to this part of the site where you can download the current COVID-19 cases in the US. Each point represents a county in the United States, and this is updated every day. Today's 3/30/2020, and that was updated 7 hours ago. And you would just go over to download, and I would do the full data set as a shapefile. And it'll come as a zip. And then I also have you grab all the counties that are generalized for the United States. Again, download that as a full data set as a zip. All right? Okay. I usually start my ArcPro projects by creating the project, and then I go back to the folder that it creates, which would be here, and then inside the US COVID-19 folder that it created, because that's what I named it, I add a raw data folder, and then I unzip my 2 layers inside of there. You can see it. Here's the cases just as a point shape file. All right? And then I add them to a map. They'll come in as WGS84, but because we're going to be mapping polygons, aerial units, right? We want a equal area projection. So I go inside the map properties here, and then I set the XY coordinate system to NAD83, contiguous US Albers. So nice equal area projection. All right, the other thing to note is that the data that they provide on the Esri site for COVID cases in the United States is point data. And in order to do dot density mapping, it needs to be in polygons. So we're going to need to get all the attributes from these points into the polygons. To do that, go over to geoprocessing. And you could search under Find Tools for the spatial join, but because I've used it a few times recently, it's right here in my favorites. So you open up the spatial join, and then the target features are going to be our counties generalized, and then the join features are going to be the COVID-19 cases in the US. Okay, and then I'm going to send it out to the geodatabase for the project. So I'm already in my geodatabase, and it's going to be my COVID_counties, and I'm just going to throw demo on this because I've done it a couple times. All right, and say save. Great. And then on the environments tab, I'm going to go under output coordinate system and change this to the current map, which is going to be the NAD83 US Albers again. All right, and then back to parameters. Great. And now there's attributes from both of these pieces of data, and we don't need all of them. So I know that this LOUSA county _1 I don't need, so I'll just exit out of there. And then I am going to keep the LOUSA county because that's the state name, and then the county N is the county name, and then the county T is the total population. And there's a bunch of other stuff in here, counties P, C, W, S. Those are all just various attributes like number of white population, number of female population, number of children population, any number of minorities. Well, it turns out with this virus, it doesn't matter if you're old or young, male or female, or what race you are, it affects all of us. So we're just going to stick with the total population. So I can select this P, scroll all the way down, and I'm going to go down to long and hold down my shift, and that gets them all, and then delete them all. And then out of the points, we have confirmed, recovered, and deaths. We want to keep those. And then this active all the way down to people right there can also be removed. And so in the end, we only have 5 layers: the state name, total county population, confirmed cases, recovered cases, and deaths. I'm going to leave the other defaults. It's just going to be an intersect. You could choose, there's many different things like intersect within a distance. But basically this is going to say anytime that a point intersects with one of these polygons of a county, go ahead and add all that point data into the polygon. So we'll run that tool. Spatial join shouldn't take too long. All right, so it's complete. It worked out. It added my new layer, and then now we don't even need the point layer or the original counties. So let's put this underneath there. Great. So now we've got our COVID county demo, and over here under symbology, I'm going to change this and scroll down to dot density. Okay. And it comes up with the joint count, which is not a very helpful attribute. We're going to go down to confirmed cases of COVID, and then I'm going to go to this point and change it to a nice yellow color there, and then apply that, and then move back to the symbology tab. So for dot density, you have 2 options. You need to set the dot size, and in this case I'm going to go to 1, and then the dot value, so how many does each dot represent? And in this case I'm going to do 2, and then for the background here, I'm going to go into that symbology, and I'm just going to make the fill color like 50% gray, and I'm going to make the outline color like 10% gray, and say apply. There we go. Great. And then move back to the symbology tab. And then the symbol is going to be a dot, and then the unit is going to be persons. Great. And you can see that over here in the table of contents, right? So each dot represents 5 persons. Oops, not supposed to be 5. It's supposed to be 2. There we go. All right. Cool. So technically, with dot density, you shouldn't allow the dots to be drawn where they can't be. Under these advanced options here, symbol options, you can use masking, and you could tell it to use masking, and then under control layer, you could tell it, for example, don't place dots inside of federal lands polygons. And you could tell it to exclude the dots from these areas. I tried that, but the federal lands layer that I have is so complex. There's thousands of polygons in there. It caused the software to crash. So we're just gonna leave that alone, but technically that's the appropriate use of the dot density tool. Okay, so we could choose another attribute like des and display it from this same symbology menu. However, it would be forced to be drawn with 1 point dot size and 2 for the value. If we want to have a little bit more control, what I do is I go over here and I right click and I will copy it, and then I'm going to right click on the actual map frame and say paste, and it just pastes a copy of that layer. And so now it's on top, and I can go under the drop down now and change that to deaths, and I'm going to go in and change the color of the symbol and say apply. Great, and then go back over. And for this one, I went ahead and made the dot size 1.25 just to increase their hierarchy a little bit. Stick with one dot equals one person, but in order to see the confirmed cases, I got to go back into the background and make that have no fill color and no outline, and hit apply. And there we go. So there are the current cases in the United States of COVID-19. If I wanted to know what the actual numbers are, what I could do is just go into the attribute table for one of my layers, and I just held down the control and double clicked on the layer. And then here is my confirmed attribute. If I right click on that and go to statistics, what you will see is a chart that comes up, and then if you hit properties, and it might have already shown here, the sum is the total of that column. So we have 116,793 cases, and this was of this last Saturday, March 28th, 2020. And then we can do the same thing for the deaths. So take a look at the statistics there. And as of this last Saturday, we had 1,777 deaths. So I would make a copy of these, and then you can paste them into your layout as explanatory text. All right, so let me close these guys here. And I have actually already done that, so I've worked up these maps, and here's my current layout. So I went ahead and give it a decent title with the date that I got the data, right? A nice legend, and then here are the confirmed cases and the recorded deaths. To get the dot density legend to look how I wanted it to, I ended up creating it with the insert dynamic text tool, legend, right? But then I had to right click on it, see if it'll let me do it, and say convert to graphics when it was still dynamic, and then ungroup, and then that gave me access to all the individual parts, and I could change the size and the font and everything and arrange it just how I wanted it. And then I select them all again and regroup them, and then that lets me move it around as one piece again. Okay, so there's the layout, and then you can go to this export layout to JPEG for putting in a report or sharing in social media, whatever. Okay, all right, so back to our demo. Now we want to map a worst case scenario and a best case scenario for COVID-19 in the United States. So I'm just going to scroll down, make sure I'm in the right place in my instructions, and so I don't forget anything. Okay, great. We'll start with the bad news first. So we're going to have to calculate the values for the worst case. So if I open up the attribute table, and I'm going to hit this little add a field here, and it'll open up a field editor. And then down here, I'm going to add a field. So I call this W infect, right? And hit enter. And so that's worst case infections. I'm going to stick with the data type of along, and then over here under the numeric options, double click and choose numeric, and then I'm going to go with 0 decimal places. And the reason for that is so that we're just rounding up to the nearest whole person, right? And then up here, I'll add another field again, and this is going to be W_deaths. Hit enter. Stick with the long, and same thing with the numeric. And do 0. Okay. And in the lab, I actually have you do this first and then come back to it. But since we're here, we'll just go ahead and create the fields for the best case scenario as well. So this is going to be B for best, infect. And we'll stick with the long and numeric again. It's the thing about GIS, there's lots of repetition, and after you get used to it, it actually is a bit comforting. All right, and then we'll add another one, and this one will be B_deaths. And we'll stick with long and numeric again. Okay, and once you've made all these changes to the attribute table, you have to save it. So we'll save it right up here. Great. And once that's done, we can close this field editor. And now it should have added all those fields to the end. So there they are. So now we have to calculate these fields. So for worst case scenario infected, we're going to go to calculate field. And that'll bring up this guy over here. So W infect equals, and that's going to be the total population, right? So it's counties T, right? Times, and what was the total possible infection rate? It was 50% of everybody gets this. So we'll do 0.5. And you can always verify and see if your expression is valid, but if it's simple like this, you can probably count on it being okay. And then we'll hit run. So that's going to give us 50% of the population in each county. All right, and now to get the worst case scenario deaths, we're going to use the field that we just calculated, the infected, and we're going to calculate this field. All right, so W deaths is going to be W infect times, and what was the highest rate? 3%, so 0.03. And I know that it's going to work, so I'll just hit run. Okay, and then if you want to see what these totals are, I can just right click on the infect, look at the statistics, and then check the properties. So in the worst case scenario, with 50% of the American population being infected, we're looking at 166,208,892 infections. Wow. And then let's take a look at the deaths. In the worst case scenario, we're looking at 4,986,283 deaths. Yeah, that's a hard number to look at, right? But it's not likely that we're going to reach those high of statistics. We're just modeling at the very high end of the range, and then now we're going to also model the low end. So let's look at the B infect. So this is the best case scenario of infected. We'll calculate this field, and that's going to be counties T again, and this was 1%, right? So that's going to be 0.01. 1% of people get infected, and we'll run that. Uh-oh, parameters not valid. What did I do wrong? Oh, field name. Well, it should have had the field. That's strange. It's going to be B infect. Okay, let's try that again. There we go. Great, so it took care of that, and now we're going to do the best case scenario deaths, and we'll calculate that field. And that's going to be our best case infected, right, times, in this case, it's only going to be 0.25%, so that's going to end up being 0.0025. And then we'll run that. And then we can take a look at these statistics. So in the best case scenario, we're looking at about 1% of the US population, so 3,324,185 people being infected. And of those, in the best case scenario, we would have 8,152 people pass away from this disease. Now that's pretty low end. Just in the time since I downloaded the data on the 28th to today when I'm making the video on the 30th, we've gone from 1,770 deaths to over 2,000. So hitting this 8,000 number is probably unlikely, and in the end we'll probably be somewhere in the middle. So let me close these attribute tables. Great, so now you have these different attributes that we can map. So, and I've already done this, so if I go over to my best case scenario, so I've gone ahead and on the symbology tab for this guy, oops. You can see that I've mapped the bee deaths in red with a 1 point dot size and 1 dot value, and then I did the infected as 1 dot equals 50 persons in the yellow, right? And then for the worst case scenario, I map that as well, and that is 1 dot in the deaths column would equal 150 people passing away, and 1 dot in the infected would be 500 people passing away. And then, of course, I can take those and push those to my layouts. So in the worst case scenario, the layout looks like this. This is with the 50% total infection rate and 3% mortality. And with these vast numbers of infected people and almost 5 million deaths. Or we can look at the best case scenario, which feels a little bit better, with about 3 million people being infected and only a little over 8,000 deaths. So that's how you do dot density for these COVID data. Your numbers in the current layout will be different, right? Because if you're downloading this data anytime past the 28th, it's likely that these numbers have increased. One other thing is inside the data there's an attribute for recovered, and I wanted to map that with little green dots. However, they were all zeros in the attribute table. So hopefully that's going to change real soon, and we're going to see people recovering from this disease and life getting back to normal in the United States and for the rest of the world. So that's a demonstration on how to do dot density mapping with some current data about this pandemic that we're all going through. Please, everybody, listen to your officials, stay home, social distance, and we're going to get through this, okay? All right. Have a good evening, and we'll talk to you next time. Take care.